Hello everyone. In this video we are gonna learn vectors. You already learned vectors in physics, but in math there are a lot of differences. So let's talk about what vector in math is. Suppose something is moving. So we want to understand what that movement is. So there's two basic information we have to know, which are direction and how fast the object is moving. So these two pieces of information can be linked together to form a vector. So according to our book, the definition is it's a quantity that has both direction and the length. The length is also known as the speed of the vector. So you see a figure here. There's an arrow figure. So this arrow is a visual manifestation of the movement. So it shows you what the direction of the vector is and what the speed of the vector is. So by speed, we also mean length of the vector. So when we write vectors, we are writing for this figure, for example, A, B. First, we're writing the starting point, initial point, and then the terminal point, and we put arrow above it. So that indicates this is vector from A to B. It's also same as there's a name for this vector given in this figure, V. V, and there's an arrow above it. So the order matters here. This vector means from A to B. A is the initial, B is the terminal point. If you switch the places, it becomes from B to A. So arrow, the direction of arrow changes. So A to B is not same as B to A. You have to be careful about that. So we can express vectors in a variety of different ways. One way to express a vector is write it in component form. Component form of a vector lists the horizontal and vertical change from the initial point to the terminal point. So it's like writing coordinates plane, writing the coordinates in the coordinates plane. In coordinates plane, we were writing the coordinates as let's say round brackets x comma y. It was how you were writing the points on the coordinates plane, but in vectors we are gonna still write x comma y, but the brackets that we are using is different. We are gonna use the sharp brackets. So this indicates the horizontal change and the vertical change from initial to terminal point for a vector. Let's take a look at that figure. It is vector CD. If you want to write this in component form, you have to figure out how much you are moving from initial point to the terminal point horizontally and how much you are moving from initial to terminal vertically. So horizontally you need to go 2 units away from the initial point. From C to D, you need to go C units away horizontally in horizontal direction. So we're going to write 2 for the first component. For the second, you should go 1, 2, 3 units away from C to get D. So if you are going right, the sign of the x coordinate is positive. If you are going up, sign of the y coordinate is also positive. When you move left or down, signs will be negative. So these are how you know what signs you are using. Let's take a look at an example. Check it out one. Write each vector in component form. So vector u. The vector u is given as a figure. So let's write it as component form. So first we are using a sharp bracket. X comma y. So what is x? It's change in horizontal direction. What's y? It's change in vertical direction. So let's figure out the change one by one. So first x. So this is the initial point. That is the terminal point. From initial to terminal, how many units you should go? 1, 2, 3 units. From initial to terminal, you should go 3 units away. In which direction? In negative direction. You are going to the left. So the sign of this number will be negative. So x is negative 3. What about y? To get the final point, you should go 1, 2, 3, 4 units. You are going 4 units away from initial point to get end point, but you are moving in negative direction, as in the x, you are going down. So the sign is negative. The number is 4. So negative 3, negative 4 inside the sharp bracket will give you a vector in component form. This was the first part of the question. Second part, the vector with initial point L and this point and the terminal point M of that point. So let's write the vector first. It is asking about vector LM. L is the initial, M is the final point. There's an arrow above it. So when you find the vector in component form, you should subtract x's together, y's together. So it's x2 minus x1. Let's say xm, x2, x final is m. The initial point is L. So you are subtracting initial point from the terminal point. So xm minus xl, comma. You do the same for y. ym minus yl. So what is xm? The final point for x is m, 6, minus the initial point for L, negative 1, comma, for y. The final point is m, so its y component is 2, minus initial point is L, its y component is 1. So you are subtracting initial point from final point. So take x value for m and subtract off the x value for L, right? For both x and y, you do the same. So for the x component, 6, negative, negative, 1, 6 plus 1, which is 7, comma, 2 minus 1, 1. So 7, comma, 1 in a sharp bracket will give you the vector Lm in component form. So this is the first way of expressing vectors. Let's continue with length and magnitude of the vector. Magnitude means speed. In other words, it means the length of the vector. So to find the length, we are gonna find the distance from initial point to terminal point. Let's say your terminal point is xy. Initial point in this figure, since it's in the origin, 0, 0. Maybe you remember distance formula from grade 10. So according to distance formula, we are gonna take square root of x2 minus x1. Remember distance formula under radical x2 minus x1 squared plus y2 minus y1 squared. That's what distance formula is. In this figure, we are trying to get the distance from O to B. O is the origin 0, 0 is the coordinate. B is a point where its coordinates are x comma y. So according to distance formula, x2 minus x1, x minus 0 squared, so x squared, plus y minus 0 squared, so just y squared. So this is how you find the magnitude of a vector. In other words, the length of the vector. In other words, speed of the vector. So vector AB or vector OB here, vector OB is under radical x squared plus y squared. So let's solve a question about that. Exercise 7, question exercise 7. Draw each vector on the coordinate plane and find the magnitude to the nearest tenth. So draw the coordinates. So x is 1. The change horizontally is 1. So you go 1 unit to the right and 4 units up. 1, 2, 3, 4. You are here. You go 1 unit right, 1, 2, 3, 4 units up. So connect from 0 to 4. So this is gonna be your vector. So this is how you draw a vector. Now find the magnitude. Find the magnitude. Let's apply the formula. The magnitude is square root of x2 minus x1 squared plus y2 minus y1 squared. Your x1 and y1, since it's in the origin 0, 0, so we can directly say x squared plus y squared. Your x is 1, 1 squared, plus your y is 4, 4 squared. 1 squared, 1, 4 squared, 16, 1 plus 16, 17. Use your calculator and round it to the nearest tenth. So it's gonna give you 4 point, approximately 4.1. It says round to the nearest tenth. So after a point, you need to write only one number. So 4.1 is the answer for exercise 7. Exercise 8. Let's sketch it first. -3 means we should go to the left. Go 3 units to the left. You are here. 1, 2, 3 here. -2 means in y direction, you should go in the negative y direction. Negative y direction means go down, 2 units down. 1, 2, you are here. 3 units left, 2 units down, you are here. Let's connect from origin to that point. So this is how you sketch a vector. I was supposed to use that arrow thing, by the way. Right, for this figure also, I was supposed to use the arrow. So here is your vector. This is how you sketch it. Now let's find the magnitude, the length of the vector. So since the initial point is in the origin and x1, y1 is 0, 0, I don't have to write it again. You can just write it as under radical x squared -3 squared plus y squared -2 squared x -3 squared 9 -2 squared 4 9 plus 4 is 13. It's square root of 13. It's asking about rounding it to the nearest tenth. So use your calculator. It's gonna give you 3.6 something something. So you just need one number after decimal point. So 3.6 is the answer to the nearest tenth. So this is how you find the magnitude.